Okay, so what we're going to do is review the unit that we basically just completed in order to prepare to kind of do a home open note assessment of this unit, as it is kind of the most important unit of the year as far as 7th grade goes. So if you need any reminders, of slope and y-intercept, I have attached a picture of some of the notes to this lesson, but hopefully what you've done is you've already done the actual, you've practiced, and then you're watching this just to kind of go over things. But if you don't have your notes at home, I attached the reminder notes kind of to remind you what a linear equation looks like. But in general, just remember it looks like this, where it has the y equals mx plus b format, and the m is the slope, and the b is the y-intercept. Okay, so the number next to the x is the slope, so that is 7. And the number that's not next to the x is the y-intercept, so that's the 8. Okay, most of these are relatively simple. So the number that's next to the x, that is the slope, or the m, which is that 5. And the y-intercept, that b, is that -9. And don't forget to include the negative. So again, the number next to the x, and you'll notice the number next to the x is a -3, so the slope here is a -3. And the y-intercept is the number that's not next to the x, so that's that 12. Okay, and the final example, the slope, again, the number that is next to the x, because that's what it's going to go up by, is that 8.6. And the number that is not is that -3. So there you go. Okay, now, reminder how to determine if something increases, decreases, or remains flat. So if the slope is positive, and again, this is in the notes again as a reminder, if the slope is positive, it's going to increase. If the slope is negative, it will decrease. And if the slope is 0, or you see no x, it's going to be a flat situation. Okay, so in this case, it's going to decrease because this number here, which is the -4, the slope is negative. Okay, and the second one, this one's going to increase. Okay, because the slope, which is that 8, is positive. Okay, now in the third case, you don't see an x because this is the same as if we had y equals 2 plus a 0x. So there's no, it's not that there's no slope, the slope is 0, so it's a flat situation. Flat line, kind of like that. That's the kind of line it is because the slope is 0, or you could say you don't see an x there. Okay, now determining if something increases or decreases faster, you're going to again look at the slope. Okay, so in this case, I'm going to look at that -7 and compare that to the -3. Now these are both decreasing, but something like going down 7 is faster than going down 3. Okay, in other words, 7 is bigger than 3. Okay, or you could say -7 is less than -3, so this one will go faster. A faster decrease. Okay, so the next one here, if we look at these two, and we're again only comparing slopes. So both increase. Okay, but increasing by 5 is faster than increasing by 2. So this one here will increase faster. Okay. All right, so second page here. It's kind of hard to see because you can see. Okay, so a water jug loses 18 milliliters of water per hour and began with 500 milliliters. So if we look at this, it started with 500. So that's that y-intercept. Okay, and it's losing 18 milliliters. That's going to be your slope. So remember, we need to define variables. So here I'm just going to say y is water and x is hours. Okay, and so in this case, if it's losing 18 milliliters, it's negative 18x. But plus it started with 500. Okay, now another option would be y equals 500 minus 18x. Okay, so it doesn't matter what order you have it in as long as the x is next to the 18, the negative 18, losing every hour. Okay, so then we have the Barrick who drives at 80 miles per hour. And in this case, we're just y is miles and x is hours. And we don't have a y-intercept, or the y-intercept is 0, so we just say y equals 80x. Or you could say y equals 80x plus 0 if you like. Okay. All right, so Juliana walks at 2 meters every second and gets a head start of 20 meters. So this you can consider kind of like your y-intercept here. Okay, and this 2 meters a second is your slope. Okay, and if I say y is meters and x is seconds, so we're going to say y equals, in this case, 2x plus 20 for that head start, or the order doesn't actually matter, so 20 plus 2x would also be fine. Okay, and sorry about that stuff that's bled through. I probably should have done copies that were not back-to-back, unfortunately. So Mauricio has $300, but he's losing $15 a week. So every week he loses $15. So that slope is a negative 15 because he's losing. But he began with 300, so that's the y-intercept. Okay, and in this case, when I say x and y, x is going to be weeks, that independent variable, and y is going to be money. Okay, and I could write my equation as y equals negative 15x plus 300. Or many of you may write that as y equals, you start at 300 and you lose 15 every week. Okay. Yeah, so let me try putting like another white piece of paper underneath it. I don't think that makes a whole lot better, unfortunately. Okay, hopefully you can see that table. So this table goes 0, 1, 2, 3, 4, but then 5, 7, 9, and then 11, and then 14, and we're trying to determine if it is linear. And so just a reminder about linear tables, they should have a constant rate. Means they go up or down by the same amount every time. Okay, so in this case, 5 to 7 was plus 2. 7 to 9 was plus 2. 9 to 11 was plus 2. But 11 to 14 was plus 3. So it is not a constant rate. So not linear because it's not a constant rate. Okay, and you could also graph these, although since you probably don't have grid paper at home, that's not probably going to be an option, although you certainly could put it on a sheet of paper and kind of carefully graph it if you wanted to check. Okay, so we're going to check this one as well. So we're going to look at this, and this first one goes down 3. The second one goes down 3. Third one goes down 3, and the fourth one also goes down 3. So yes, this is linear. The constant rate of negative 3. Okay, it's going down 3 every time. Okay, now this table is a little tricky because it didn't go up by the same amount. So if you want to actually change the table, make it go up by the same amount. That's what I would suggest, since it's been a while since we looked at this specific type of problem. So I would start the table over again. So here's still my x and my y, but now I have -1. It still says -2. Okay, and then my 0 is 3. But you'll notice I skipped the 1 on this table up here. It's in the middle there. Okay, so I'll put a 1 in, but I won't give a y value yet. So I'm just still including this 213 here. Okay, and then 3 is 18. And then 4 and 5 were not included, but 6 was included. Okay, and 6 is 33. So I'm going to look and start my table and see, or start looking at my changes and see what's happening here. So from -2 to 3, I went up 5. Okay, oops, sorry. There we go. And from 13 to 18, I also went up 5. So those are the two I can see. Now let's see if I happen to go up 5 in between the two. Do I continue the pattern? So 3 plus 5 is 8. And then again, yep, plus another 5 would be 13. Okay, now let's continue that pattern and see if we hit that 33. So plus 5 is 23. Plus another 5 is 28. And then yes, when I hit that 5, it is 33. So yes, this is linear. The constant rate is 5. Okay. All right, so the next 2 pages involve graphing. So if you don't have a printer and or grid paper at home, I'll kind of show you what I would expect as far as just kind of showing me a general situation. Now these are all going to be linear, so I'm just going to look. I need a slope, which is that change again, or that rate of change. Okay, and I'm going to need a y-intercept, and if you look back in the notes that I included, that's going to be that 0 value when x is 0, or where it crosses the y-axis as well. Okay, so in this particular case, if I look right here, that's my 0 value, and my value is 7. So 7 is your b, so it's your y-intercept. Okay, and now if I look at what's happening every time, this is going down by 1s. And that's going to be your slope. So when I write the equation, I would just write y equals -1x plus 7. Okay, it can be in the other order if you'd like. 7 plus -1x, or 7 minus 1x. Those are both fine. Okay? Now, if you have grid paper, you can kind of just graph it directly, but I know most of you will not. So as far as showing a graph, so that would kind of be if you have a printer and grid paper and that sort of thing. I'm just going to use this kind of edge of the paper mate container as my, line. Okay, close enough. But if you do not have grid paper, which I assume a lot of you won't, then you could just draw a line on a sheet of paper, and all I really care about is that I can see kind of what's happening in general. So you would show that y-intercept. So let's say 1, 2, 3, 4, 5, 6, 7. So there's that 7 y-intercept. And then you would show me kind of that it goes down by 1s, something like that. Okay, not a real big deal as long as I can sort of see a general idea as to what's happening. Just kind of show me a real general idea. So that would be fine if this was going like 1, 2, like that. Okay. All right. We'll skip this one because the next one was meant to have a graph on it, but well, actually, why don't I make a graph and then I will. Let's not worry about number 13 here. Let's move on to 14. Okay, so 14 says y equals 250x. So in this case, I'm just going to multiply this x value here by 250. So 250 times negative 2, which would be negative 5. And 250 times that negative 1, which is negative 250. 250 times 0, which is 0. And then this is going up by 250 every time. So there it would be 250 and 5. Don't worry too much about the graph for that one, because as it's going up by small amounts, if you only have paper, it's not going to work that well. So a situation this might represent. For example, I spend $2.50 on every bag of chips I buy. So amount paid, that's it. Something like that. Okay. And so the last question for today, or the last example going over for this class, is this person earning $2.50 per mile but getting a $1 donation. So this $1 donation is like your y-intercept. Okay, and the slope would be 250. So you would start this as $1, and then it would move up 250 every time. So 350 and move up 250 again. So 5, so 6, and up 250, which would be 850. Okay. Again, let's not worry about the graph as you don't have grid paper. Is this linear though? Yes, because it has a constant rate of change. Okay, and what are the variables? What does x and y represent? X in this case was miles, and y was money. Okay, and our equation would be y equals, in this case it's adding 250 every time. So y equals 250x plus that original amount of that dollar. Okay. All right, and that is the end of the first 2 full pages of reviewing for this unit. Have a great day.